All right, let's pull back the curtain on something that can seem kind of intimidating, computer programming. But what if I told you that in the next few minutes, you could actually start to get it? We're going to see how anyone, and I really do mean anyone, can start speaking the language of computers using Python. Okay, let's just dive right in. You know that feeling, right? You're renaming 100 files one by one, or you're copying and pasting the exact same bit of info from one place to another over and over again. It's tedious, it's boring, and the whole time you're probably thinking, man, our robot should be doing this. Well, guess what? You can build that robot. And that's really the whole idea behind learning a language like Python. It's not about some Hollywood hacker movie stuff. It's about automation. It's about giving your computer a list of instructions to handle all that boring, repetitive work for you, so you can get back to the interesting stuff. So how do we even begin to give the computer instructions? Well, first things first, we need a way for the computer to remember things. Just like we have nouns in our language to talk about people, places, and things, a program needs a way to hold on to information. And it all starts with one super basic building block. This is it, a variable. It's honestly that simple. It's just a name that you make up to hold onto a piece of data. Could be a number, could be a word, you name it. And that labeled box analogy, it's perfect. You're just putting something inside a box and slapping a label on it so you can find it again later. And check this out. This is exactly what it looks like. When we type x equals 30, we're literally telling Python, hey, see this number, 30? Put it in a little box for me and just label that box x. Now, anytime our program needs that number, we just say, hey, go get what's an x. Simple as that. Okay, so storing one thing at a time is great, but let's be real, life is usually more complicated than that. We almost always have lots of related pieces of information we need to organize. So let's look at how we can group all that information together using what are called data structures. First up is a list. If a variable is a single box, you can think of a list as a whole shelf of boxes, all lined up in a specific order. And you can change what's inside them anytime you want. The shopping list analogy is spot on. So look at this. We make a grocery list, right? It's got milk and eggs. Then we realize, oh shoot, we need bread. No problem. We can just use a little command to tack apples right onto the end of our list. We don't have to start over, we just add to it. But what if the order doesn't really matter? What if what you really care about is having a specific label for each piece of info? Well, for that, we have something called a dictionary. Forget the shelf of boxes. This is more like an address book. You don't care if Bob is the first or the last entry. You just want to look up Bob and find his phone number. And this is how it actually works. Instead of using a position like 0, 1, or 2, we use a unique key, that's our label, to look up its value. It's the difference between asking, what's the first thing on the list, and asking, what's the phone number for Bob? It's a way more direct way to find information when you know what you're looking for. So, here's the bottom line. It's really simple. You use a list when the sequence is everything, like the steps in a recipe. You use a dictionary when you need to look things up by a specific, unique name, like finding an employee's ID number. Order versus label, that's the key difference. Okay, so we know how to store information. Now for the really fun part, telling the computer what to do with it. We're moving from the nouns of programming to the verbs, the actual actions. This whole idea is called control flow, and it's crucial. A program isn't just a straight line of commands that runs from top to bottom. A good program can react. It can make decisions. It can choose to go down different paths based on the information it has. And the most common way our code makes decisions is with something called an if, elif, else block. And it's pure, simple logic. The computer checks the first if condition. Is it true? Great. It runs that piece of code, and then it's done. If it's false, it just moves on to the next condition, the elif, which is just short for else if. And if none of those are true, it'll just run the final else part as a default. Now, what if you've got a set of instructions you know you're going to need to use all the time? You don't want to write it out every single time, right? Of course not. That's where functions come in. A function is basically a recipe. You write the instructions once, give it a name, and then you can just call that recipe whenever you need it, even with different ingredients. I mean, look at this. It's so simple, it's beautiful. We've made a tiny little recipe called square. It takes one ingredient, a number, and the only instruction is to multiply that number by itself. Now, instead of writing 5 times 5 or 10 times 10 all over our code, we can just say square 5 or square 10. It's just so much cleaner and easier. All right, we've got all our little Lego bricks, variables, lists, dictionaries, functions, and decision-making.
They're all cool on their own, but the real magic, the real power, happens when you start clicking them together to solve an actual problem.
So let's imagine a real-world problem. Say you have a massive list of items. I don't know, maybe sales data. And your boss wants to know how many times each unique item appears. Doing that by hand would be an absolute nightmare. But with the building blocks we just learned, it's a piece of cake. And here's how we do it. Now, don't get hung up on the exact words here, just look at the ideas. We use a loop to go through every single item on our list. For each item, an if statement makes a decision. Have we seen this one before? And we use a dictionary, our address book, to keep a running tally. We are literally using every single thing we just talked about all together. And bam, just like that, in a handful of lines, you have built a little data analysis robot, and it doesn't care if the list has 10 items or 10 million items. The instructions are exactly the same. This, right here, this is the superpower of programming. You're telling the computer how to do the heavy lifting for you. So there you have it. You've just seen the fundamental grammar that powers so much of our digital world, storing stuff, organizing it, and making decisions about it. These aren't just abstract ideas. They are real, practical tools. So the only real question left is, what's that boring, repetitive task in your life that you're going to solve first?